Okay, thanks everyone for joining in today. And we have a very interesting topic today. That's IoT cloud and core smart applications. So this is actually an initiative that we are going to take in Pakistan with the association of Pasha that we'll be introducing different courses, different webinars and knowledge sessions about IoT and smart applications. USMAN is the former solution architect in Intel and also worked as a solution architect in Monash University. USMAN definitely go into more details about the introduction. But this is the second session on IoT that we are launching over here. And once it's done, we will also be launching few more knowledgeable sessions and the courses as well in Pakistan. So the major purpose of bringing these kind of sessions for Pakistan's audience is to educate them, and also with the support of Pasha, we will be trying to support all the individuals and the companies to get proper hands-on experience on IoT. And Usman, thanks very much for joining in. Usman is here in Pakistan for some time from Australia. So I'm actually trying to buy some time from him that he can share some knowledge with us. Over to you, please.
Thank you very much, Mohsen, for having me here. And just one few clarification which I want to get. The first one is everybody able to see the slide and can hear me?
Yes.
Yes, sir.
That's great.
Yes, Usman, we are able to hear.
That's great. That's great. And secondly, Mohsen, so when you mentioned earlier about courses and the webinars, so it is basically primarily based here in Pakistan, but it is also open for people which want to join from outside Pakistan, right?
Yes, definitely.
Okay.
Since we have community and everything in Pakistan, but definitely we prefer this is open for everyone globally.
Okay, sure. Thank you. So let me just jump into it. Again, thank you very much, Mohsen, for having me here, and a good evening to everyone.
Good evening, good morning as well, because there are a few people who are outside Pakistan just joined in. So whatever you're in.
Thanks. Good morning, good afternoon, good evening to everyone, and let's jump into it. Okay, first of all, about myself, I'm standing here to give this presentation. I have been working in the software industry for the last 19 years, and the 12 years out of those 19 are primarily in Internet of Things area. I started working in IoT back in 2008. Primarily the main area was the R&D related to embedded devices, the connectivity aspect, protocol aspect, security aspect of it. And then I worked for Intel a couple of years, roughly 5.5 years. Intel has been one of the biggest players for IoT. Their annual revenue is roughly $3 to $4 billion, only coming out from the Internet of Things business. And I was one of the architects, worked on key projects, which also relates with different type of core series as well as Atom series. Mostly the Atom series were used for the gateways, whereas the core series systems were used for edge computing and most of the high-end compute-related requirements. So like in Intel, I worked not only for the core project, but I got an opportunity to work with ZP Lines as an Intel global license, as well as I worked with alliances like Industrial Internet Consortium, OPC, Avenue Lines, and a couple of more, where the key thing for me was to basically put forward some of the stuff that we are doing in Intel, but also getting in to the company what the industry is going forward to. Furthermore, I look at the ecosystems, build ecosystem from an open source perspective, as well as making standardization where different vendors can talk to each other. In the most recent last 2 years, I've been working on a smart city project as a solution architect, project manager, and product manager, which is for Monash City Council in Australia. Monash is a city which is basically very near to Melbourne. It's roughly like 20 minutes drive from Melbourne central area, and most of the universities as well as the tech companies are in Monash area. So I primarily work for the smart city project, whereas as a voluntarily, I've been working with the Australian technical standards, where I'm one of the committee members for smart cities and 5G related work. So just to wrap it up, basically, I've been working IoT area for the last couple, like 12 years or something. I have 25 patents within the IoT space, 24 publications, and already been presenting in various international conferences and forums, and primarily advocating about IoT solutions. The key agenda for this item would be, this presentation would be, we'll be drilling down to the core concept of IoT, edge computing, and cloud. And then we'll be understanding about why is it so important towards the smart city smart applications. Mostly one question here. I'm getting one yellow color line on the screen. Is it possible to remove it?
Yeah, let me try that. I think some participants, they tried to imitate, but anyways, let me try that to remove it.
Sure, please. Thank you. So before we jump into IoT, generally speaking, when we talk with people from different backgrounds, there is a general opinion about the IoT, Internet of Things. So what people normally think about is that we have a bunch of devices, embedded devices, or IoT sensors, which connect with certain type of access point. It's a gateway, and the gateway sends the data to some type of powerful server or PC, which provides analytics, as you can see. But when you jump into the actual projects, especially when you're working with the customers, it's actually a very different landscape. The landscape actually looks like this. It's a very complicated landscape where we have a lot of different type of technologies in each domain of the technology. What it means is when we talk about, for example, IoT devices, there are different type of IoT devices platforms. We talk about connectivity. There are different type of connectivities. For example, Zigbee to LoRaWAN to Sigfox and so on and so forth. And similarly, when we talk about the edge computing and the cloud, there are also a lot of options there. But primarily, one of the biggest problems, which was there for the last 5 to 7 years, it was with the standardization. Standardization in terms of sending the data from the actual devices in a more unified or standardized format, as well as in a standardized way of communicating or connecting to the network. And there are other operations and features which are critical for actual solutions. So what we are seeing here is 50 lanes on the Hong Kong-Macau Expressway, which converge into 20 lanes. And this is what's happening for the last few years in IoT space. We have, different type of technologies coming in, but now they are consolidating by, grouping together. As an example, Zigbee Alliance has created a very, I would say, optimistic ecosystem where they're basically bringing in most of the people which are working in 802.15.4 space, as well as BLE, and agreeing on something which will be more acceptable by different type of vendors and device manufacturers eventually. So even though we saw previously there was a big challenge, but there is also a big opportunity. So each challenge brings opportunities for not only for technical people, but also for businesses. We have been, informed by different type of research organizations, business organizations, strategy organizations, and so on and so forth, that we're going to have more than 50 billion devices in the next 5 years' time, which already has started since last year, and it's going to have tons of technical devices, for example, mobile devices, sensors, actuators, gateways, powerful industrial PCs, powerful smart cameras, and a lot of other stuff, which is going to be part of the next wave of technology. This wave of technology is a bit different than what has happened 20, 25 years ago with the internet. in this wave of technology push, it basically has enable different type of use cases as well as application, which was not enabled previously. And one of the primary reason it is because with the economy of scale has changed, where previously the devices and softwares and so on and so forth were expensive to build, but nowadays they are with the advent of globalization in some way and also digitalization requirements and manufacturing a lot more devices. It basically helped to create those devices which are more affordable to build and also integrate into next generation applications. We will know more in a short while, but the key thing here is that we have an opportunity of more than 50 billion devices, which are going to have a 40 plus zettabytes of data generation. 1 zettabyte is approximately 1,000 exabyte, and 1 exabyte is basically 1 billion terabytes. So we're going to have a lot of data coming in over the network, over the devices, over storage, and we can do wonders with that.
Usman, sorry to interrupt you. I have a quick question because I would like to map the understanding of the audience as well. Because I'm expecting, like most of the people, they're expecting more of a generic knowledge about IoT, and they would like to map their understanding in case that how IoT is helping the current industry or the current globalization, and what's its role for the smart applications. Because I think this is not very much technical audience, but still being our audience myself, I will be looking for something, okay, so how IoT is helping or can help our industry as well.
Sure. What I'm doing is I'm going step by step. So initially I'm trying to give a holistic view, and then I will go step by step toward the direction which will explain the main topic. But I'm trying to build a story here. For example, I will try to connect back to the traditional IT systems and then connect forward to this, the IoT-based solutions.
Sure.
And please basically ping me whenever you have any confusion, any of you.
Yes. So guys, if you have any question from any perspective, you can definitely jump in.
Yeah. Because to be honest, what I want to do is that by the time you finish this webinar, I want to, it will be great that you basically spend your time in learning and understanding something which you can use in your work afterwards. So, okay, before I jump into defining IoT, the thing which we want to understand, which we already know, is also that what is the internet? And as you know, the internet is the global network of, it's a global network providing a variety of information and communication facilities consisting of interconnected networks. And as you know, that there are different type of routers and the servers which are connected over the standard networking infrastructure. So internet is somehow, in a very generic way, we can understand from this Oxford reference. Whereas Internet of Things is a bit different, which is the Internet of Things describe the network of physical objects, which are normally called things, and that are embedded with sensors. As an example, when you talk about pumps or you talk about, in the factory environment, there are certain type of, belts or, robotic arms and so on and so forth. So those physical objects, or this physical object, like, in the smart city environment, we have a, waste bins, or we have, the poles, or we have parking spaces. So all these type of different assets or object or use cases are being connected with certain type of technology, which includes sensors, which basically has an ability to have a software and other technologies to basically sense the data and then transmit over the internet in a certain way. So in a nutshell, when we talk about IoT, it consists of a computing unit, which attached to some type of physical object. And that computing unit must have a way of connecting to outside world. And while it's connecting to the outside world, it must be secure, because if it's secure, anybody can basically affect the actual operation of the system. And thirdly, it must be managed, because if we are transmitting a valuable data coming out from a pump or from a parking sensor or from a waste bin or a smart camera coming out from a home, it needs to be managed, because if basically we transmit data, we basically have devices which are not having their own identification, it would be very challenging to make them connected. So there are a lot of work which has been happening in all of these areas for the last 10 years. And the key thing, which was also mentioned in the definition by Wikipedia, that it needs to provide a data. So computing, connectivity, security, and manageability in the end provided data, which is being used for getting the insights or data insight, which could be used for decision-making processes. And I will give some examples later in the presentation from the smart city project, which I've been working on with the city council, what type of insight we have gotten from the data. So the key elements of IoT from the hardware perspective. Yes.
Sorry to interrupt you in between. Just wanted to just a quick question. Want to know,
sure,
is there any difference between IoT and IIoT? Like I have listened and also read somewhere that IoT things, and somewhere written it is like industrial Internet of Things. Is it same thing, two different words, or the technology or things are different? One point I wanted to know, and on the previous slide, you also mentioned something machine learning. Would it be possible to relate some example with the how things will help, like inside data analytics and machine learning? Because nowadays machine learning and AI stuff is too much in the market. So I just wanted to know how this will help in terms of machine learning. This is my second question.
Sure.
Thank you.
I will be very quick to answer it. Basically, industrial Internet of Things is the subset of Internet of Things. And there are certain requirements which industrial Internet of Things do, which don't normally IoT doesn't do it. As an example, a quick example would be a sensor in a factory environment need to be operated 24/7 in an environment which could be 120 degrees Celsius. So we may see a couple of examples later on as well. Same with the machine learning. I will give an example from the project which I've worked on. I mean, what type of parking data we have basically collected, and what we did with the parking data based on the machine learning and deep learning, the analytics that we did. Just hold on for a while for that example. So the key elements of IoT. The key elements of IoT from what I explained earlier in the slide, in the definition, that there is a hardware or computing aspect, which, as you know, has different type of embedded devices. It has sensors, actuators, as well as it will also have high computing devices like gateways and edge computing. From the connectivity perspective, these devices connect over a specialized type of connectivity technologies. It's not a normal Wi-Fi or a Bluetooth. It is basically, it has a Zigbee, it has a LoRaWAN, it has a couple of other stuff which I will explain in next slide. But the key thing which I want to show here is from a holistic view that there are differences here. Similarly, we have to manage these devices, especially when in the earlier slide we have seen there are going to be 50 billion devices. So 15 billion devices, just imagine that we need something new to basically work out with them to really manage it. For example, if we talk about IP, Internet Protocol version 4, that would not be possible to use IP version 4 to manage these devices. IP version 6, probably there will be a way that we can manage the devices in certain way. For example, the 6-LoWPAN was invented almost 10 years ago. to basically solve the problem with the identification related problem in the manageability domain and also communication. Then, of course, we need to take care of the security aspect, which I've been earlier, and last one will be analytics and AI, which in the end will basically generally speaking, when we talk about architectures for the ICT applications, we have something like this, which I think most of people will be aware of, where we have on the right side, we have server, which is running on a Windows and Linux operating system. And there will be certain applications which are running on top of the server, and they talk to, different type of databases sometimes. Now, in some cases, in an office environment, those applications are accessed through a normal clients, which runs on the PC. In other cases, it could be run over the internet using web or mobile apps. We also have seen a new model where cloud-based applications are getting common, where we have, again, something similar type of model like before, but it is more scalable and easier to do a lot of different type of operations such as we can handle the scalability of application and services according to users which are accessing it over the internet. So, but again, here, applications like payrolls, applications like ERP and CRM are running in these type of models, which most of the people already know it in an entire architecture perspective. But when we talk about entire type of architecture for IoT, it is a bit different. The difference comes here where, as you can see, we have the cloud services, which also run some type of similar applications or similar services, which we have seen earlier. But then we also have a model where some type of client access these services either using PC or a web browser or a mobile apps. But on the other side of the horizon, over the internet, we have edge computing and connectivity solutions such as gateways. Then we have different type of operating systems running on top of it, and then applications which are providing certain type of functionalities there. And beyond that, we have an IoT network. Why we mention specifically IoT network? Because these devices, a physical asset, these are the devices which are embedded with 8 kilobytes of RAM or 16 kilobytes of RAM and 128 kilobytes of ROM, which includes the actual embedded FreeRTOS type of operating systems or firmwares. And their operation is a very specific operation. It simply sends the data, but it will actuate something and send it over the IoT network. These IoT network means that these IoT devices would not have an IP address. These IoT devices will have a very specialized or low power type of features, such as they will have their own identification system. The security system will be very different than the normal IP network. The security system will be depending on using some type of authentication type of protocol.
Usman, I have a question.
Sure.
What is the difference between 3-tier architecture and N-tier architecture? Like, is it the same? Are they both same, or what's the difference?
Basically, N can be replaced with different type of numbers in a nutshell, which means you could have a 2-tier, 3-tier, 4-tier, and so on and so forth. But we use N-tier because it will become a bit easier to comprehend. So as we attach more and more entities in a solution or a system, then it will be easier to comprehend. So what you mentioned about 2-tier or 3-tier, the N is reflecting that part.
Okay, so you mean multiple layers. We're
Yes.
adding multiple layers here. Okay.
Yes.
And they're all separated? Like the primary or secondary, they're all separated, or?
Yeah. So like in the case of tiers, sometimes those tiers on a physical system could be running in multiple layers there. For example, database will be one layer, The servers could be another layer, application will be third layer. And then when it talks over the internet and a PC or a web browser or mobile app is connecting to those services, that could be fourth layer. So it will actually build in that format.
Okay, got it. Thank you.
No problem. So Internet of Things, based on what we explained so far, they are having a very different type of requirements than the normal ICT requirements. For example, in the case of the first point, which is broad customer base, what it means is that the customer base which is required for a PC, which is required for a car. In the cars, there are also computing solutions. There are factories which have the industrial PCs. There are ATM machines, there are credit card machines, there are smart bulbs in the house. All of them, they have a very different type of technical needs as well as the software and hardware requirements. So one vendor would not be able to provide all of those requirements. So there's a big segregation of vendors, and there is a big segregation of ecosystem. As compared to PC, where we know we have Acer, we have HP, we have Microsoft, we have a bunch of different distros in Linux. In the case of IoT, there are a lot of different type of customers here. And personally, I've worked with industrial IoT customers such as I work with Ericsson, I work with GE, and ABB. On the other scale, with the car companies like BMW and Toyota, which basically use a specialized computer for the cars. And similarly, when I work with the smart city project, there are different type of vendors there and different requirements, which I might discuss, or we can also discuss if we have some time on it. Now, the second point here is operating systems. In the case of, when we talk about PC, we have primarily Linux, Windows. In the case of mobile, we have Android and iOS. In IoT space, we actually have a lot more OSs. There are hundreds of OSs and different variants of it. So now just imagine who are gonna build the drivers or build a solution for it. So there is going to be a lot of segregation, but there is a community which supports it. The third point here is long life. Long life in a way, just imagine when you're going to put a sensor in a parking bay inside the road, and those sensors are not connected with any main power supply. So the expectation is that those sensors need to run on a battery for 3 to 5 years, roughly. So generally speaking, how they work is they turn on, they receive the data from the sensor, they transmit, and then they sleep. So the requirements are basically given by a parking operator or a specific solution requirement, which basically put into the system. Next one is the bandwidth and latency. Again, we have a very big landscape here because there are certain applications which requires data in a like 10 to 20 kilobits space, whereas certain applications like cameras requires in 10 plus megabits per second range. So a functional safety aspect is also very critical, as I mentioned earlier about industrial IoT, where we basically put those devices which are being used by machine operators. So those factory machines need to work 24/7. If something goes wrong with those computing systems, they need to elegantly stop, rather than having something like a blue screen, which normally we see in Windows in the last couple of years. So the requirements are kind of very different from the ICT solution requirements. And this is only the high level. Once we go more deeper, it's also a lot more details there. So let's jump into what is IoT edge devices here. So IoT edge devices are generally attached or incorporated with the physical systems or assets. And the primary objective here is to monitor or actuate something. So as an example, we have these type of different devices. From the left, it's more like a prototyping type of devices. And then we have a couple of sensors, such as we have IR sensor, And then on the right side or middle, we can see that different type of prototype type of devices, once they go into commercialization stage, we can see devices like these. Here in the middle is the parking sensor. After parking sensor, we have a bin, and bin is a waste bin sensors. Alexa is also considered to be an IoT device, and then the different type of smart cameras. And what does it really do? It basically enables applications like these, where on the first application on the left, we have smart bins. So we take the normal bins, and there's a way that we can attach those bin sensors. And once those bin sensors are attached, then we have to configure about the network that they can communicate with the gateway and then network servers and eventually to the cloud. Similarly, on the second picture, we have smart parking example. Third picture, we have a smart bulbs example. And lastly, we have examples of smart poles. These smart poles primarily not only provide the light, but we can connect these different type of sensors like environmental sensors and proximity sensors, smart cameras, and so on and so forth. Now we look at another aspect, which is connectivity, because a lot of people get confused with the connectivity of IoT devices. So one of there are different technology, but I'm going to just talk about only a few here. So we have a connectivity from IoT devices toward the gateway. And in this space, we have Zigbee is one of the examples of one of the technologies, which create a star and mesh type of topology with around 250 kilobits per second of the bandwidth. If you compare with the Wi-Fi, mostly that we have at home, the Wi-Fi provides us minimum 100 megabits of speed. And Wi-Fi access points at home are connected with the power supply. But these are Zigbee devices, they consume a milliampere of power, and they mostly operate using a battery, so they can last for a couple of years. Second option for us is a LoRaWAN, which also has a very low bit rate. But the key thing here is that as compared to Zigbee, which provides us the range of roughly 100 meters, LoRaWAN can give us a range of a couple of kilometers. So if you're talking about applications specifically for agriculture or a smart city application, LoRaWAN is a good option. We also use LoRaWAN and Zigbee in our project for smart city. Another one is Bluetooth. It's a BLE specially designed for IoT applications. The key difference here is the data rate is higher, and while having a higher data rate, we also have a range of 10 meters to a couple of 100 meters range, depending on the deployment area. A lot of people talk about cellular technologies to use with the IoT, and one of the key technologies is narrowband IoT, which is an extension of a standard coming out from LTE. As you can see here, that generally the uplink and the downlink speed is from 26 to 66 kilobits per second, which is very low. But again, it is being used with the smart meters. For example, when we want to get the meter reading, and normally we don't do meter reading every day. We do meter reading once a month. So the applications are again very specific here. Lastly, on the front hole technology side, we have a Wi-Fi. The Wi-Fi are normally used for cameras here, as compared to other sensors, because as you know, when we are going to sense or we're going to capture a video, we need a more higher bandwidth, and the cameras are normally connected with the power. The rest of the sensors are mostly not connected to the power; they're connected with the battery. On the other side of the landscape, we have again Wi-Fi, but getting hundreds of megabits of bandwidth. We have a cellular technology, which is 4G or upcoming 5G, provide us hundreds of megabits of bandwidth or speed. We have Ethernet, which is a cable-based technology. We have a fiber-based technology. Okay, why we need different landscape here? So the IoT devices connected over the IoT network to a gateway. Now, IoT devices doesn't have IP address. So a gateway is required, which translate in certain way a non-IP address of the devices to a sometimes internet protocol-based device addressing, or in some other type of address translation mechanism. Once it's translated, then we use different type of these connectivity technologies to connect back to the cloud. Are we good so far?
Yes, I think there is one or two questions on the chat. You can also check, but maybe we can do this in question and answer session.
Sure. The next one is the edge computing, which is the the second part of the picture, the middle part of the picture. So it basically connects the IoT devices, as I explained earlier, to the cloud. But in doing so, it does also do processing of the data. So in the first context, if the devices doesn't have any IP address, Internet Protocol v version 4 addresses, so it will change it to a format which allows the cloud to reach to it. In the second purpose is to provide a low latency decision-making applications. What it means is, when we put the cameras on a edge, in a smart cameras, generally we don't have a high processing compute solution there. The high processing computer solutions are mostly in the edge or edge computers. So the video stream from tens of computers are coming into a specialized computer, which detect if there is an anomaly on a scene, such as if the traffic is moving from one direction to another direction. So it will actually monitor the number plates and cars itself. Like some of you may have already gotten summons from the traffic, where whenever you do overspeeding, there is a certain ticket generated based on, again, some sensors are there, some technology out there which is used. So I have a picture which can show, which can elaborate it further. So devices which are being used on edge gateway or computing devices are something like this mostly. On the left side, we can see these are different type of gateways. In the center, we have an edge computer which is more powerful. Sometimes it's like a Xeon base, having FPGAs as well as specialized graphic cards. On the right side, we have network video recorders, which primarily, again, perform certain type of analytics as well, besides storing the data. And the key examples here are, on the right side, you can see different cars are having those boxes, and different people which are moving from one direction to another direction. So these type of operations are nowadays generally doing on the edge side rather than the cloud, because just imagine that if you're gonna record a video which is 30 frames per second, and we're gonna send each frame all the way to the cloud will process it and send it back, it will be too time consuming. So most of these operations are nowadays done on the edge, and the summary of the result is sent it to the cloud. The second example on the left is connecting a different type of sensors and actuators from the IoT devices to the cloud. The cloud services perspective is primarily it connects the IoT network to the gateway and other devices with the purpose of collecting the data. And once it's collected data, it will do encoding and decoding of data. What it means is, as I mentioned earlier in my first couple of slides, that there are a lot of different ecosystems, there are a lot of different technologies. All of them are sending the data in their own formats. So in some cases, those encoding formats are implemented on an application level on the cloud services. So once they receive the data, they will extract the data and probably put it into a JSON type of format, which will be consumed by the applications and then stored into a database for the processing. So as people might know here, that on the cloud side, we have infrastructure as a service. And infrastructure as a service for IoT services, there are different players in the market, such as Amazon, Google, Azure, Alibaba, Huawei, and IBM. A platform as a service, again, there are similar players and also more players available. And then we have a software as a service. In a software as a service, we have different type of companies providing a solution which basically collects the data, use those services provided by the underlying uh, managed cloud services provider, and then they do different type of operations, including the simple operations like collecting and processing data, and the advanced operations where they do machine learning and deep learning based algorithms and inferencing to use a certain type of insights, which I will also explain in a later slide. I mentioned here different companies, including PTC to ThinkWorks, and then I also mentioned custom built platforms. The reason to put custom built platform because when I started working with the Smart City project, what we found and what we did, I worked directly with the Smart City, with the City Council, Manal City Council, and asked them about the requirements. What we found eventually that many of the service software as a service providers, they provide a generic solution for most of the problems, they think, because their technology is a push-based technology rather than a pull-based technology. A push-based technology means that the company comes up with their idea and they basically push the technology for others to adopt. Pull-based technology means that a company like a city council or an agriculture farm or a factory, they actually provide you the requirement and you basically implement it for them. So that's what we did with Smart City project. We actually take those hardcore requirements. I discussed directly with the CEOs and senior management of the city council. I work with and understand about the normal staff which are working in the field, and then get those requirements and create the solution which is required by the city council. Now these are a couple of major examples of IoT solutions or smart applications. The first one is the smart home, and in a smart home environment, the key thing or the key application that mostly people sell is the automation. So generally they automate different functionality of the house, such as, they put sensors on the windows and the doors for the security purposes. Then the cameras are there to monitor who are the owner of the house and who are not. So there's the whitelisting. And then there are speakers, there are other different type of sub-use cases there. Generally speaking, the market size for the smart home is $135 billion as of now. And they're looking at this market size will be there at least for 2025. Second one is the smart factories, or generally from the context of Germany, they are basically calling it Industry 4.0. And from other aspect, it's also industrial IoT. These type of applications again requires a certain very specific type of devices attached to the, like robotic arms, to the belt, which basically has different type of products moving on the belt for packaging purposes. And then there are many different sub-use cases in a factory, which I think we must have seen from different type of documentaries before, or maybe have experienced from the factories. So in this case, we basically again have the devices, we connect to the gateway, which connect with the edge computing, and then eventually with the cloud. That cloud could be a hybrid type of cloud model, which means something may be residing on the factory, something will be residing somewhere on the internet. And the market size is around $422 billion until 2025. Then we have smart cities, which currently I'm working on. Previously, I have worked with smart home and also for the smart factories while I was working in Intel. Currently, when I'm working for the smart city project in Australia, this is my area right now. So this one consists of so many use cases, and the primary objective, or primary purpose is, first of all, how we're going to make the operational of a city council more optimized, such as one of the example which was given to me, that you must have seen sometimes in a city environment you have different type of gutters or sewage systems. So normally when the sewage system gets filled and the water start coming out on the road, then people complain and that complaint goes to city council. Somebody will come from city council, will do the reporting, will go back to the city council, will create a work order, and eventually after a week or two later, somebody will come and fix it. And it really affects the quality of life of people which are working or living in that area. In another case, it actually affects the ranking of a city council, which what type of services they are providing to the residents. So smart city solutions or end-to-end smart application in this context, using the sensors and overall, the way I have explained earlier about the solution, provides a timely manner information. What it means is that the city council would know before it happens that there will be a some type of clog in the sewage, and this is one of the sub-use cases we have delivered to Muna City Council. Then there are many other use cases, which includes safety aspect of people, a security aspect of people, managing of the parking, and so on and so forth. So it's a very big market, $2 trillion market. Lastly, I give an example here of smart agriculture, and the primary purpose is to understand the resources, the limited resources that we have. For example, the water itself, which is given into a farm, we have a limited resource of water, clean water. So using the sensors, we know how much water is good enough to give to the let's say rice paddy field. Similarly, we will know what is the right time to cut the crop. So those type of tangible insights and data will be given by using an end-to-end IoT cloud type of solutions. Now, this is, I have taken out from the dashboard that we have created for a smart city project in Manaj. On the left side, this is the pilot project area in Oakley, where we have deployed around 700 parking bays, 700 parking sensors. We have deployed tens of bin sensors. We have deployed tens of pit sensors and LiDAR and smart cameras to do monitoring of that area. And I mentioned pilot because there is no city council, or there is not going to be any company which is going to roll out a full-scale smart city project for the whole city. We want to understand first in a small area, like in this is a few kilometer area, we deploy this type of smart technologies and we understand how it works, what type of benefit it will give. And based on those, we will basically do our data insight and decision making. So on the right side, I have a couple of analytics or charts here. On the top, we have a live parking data, which is part of their city dashboard, which run on a big screen. They can see that how live data, parking data information is coming for occupancy and vacancy. Then the second chart shows them individual cities, so individual parking bays, what is the occupancy rate there? And then we have a monthly parking data, which shows, for example, in the overall month, what is the occupancy rate there? Here, there is something interesting. This data is coming from last year. So you can see in January last year, it was 87% occupancy rate. But February, March, April, it goes down. And the key reason was the lockdown because of COVID-19 last year. And then around June time, they basically opened up again for the public. The bars were open, the restrooms were open. And after July, it again dropped back for the lockdown. And the lockdown was there for 5 to 6 months. So we get some type of tangible data which basically give us insight. Now, another aspect is, based on the parking data, we know which parking is more like a hot plate, or is basically more in demand as compared to others. So the city council parking team can give a different type of rates in those areas, especially during the peak hours. So previously they can't. Previously they were using a traditional system, but now they can. Then we have here, bin sensors and pit sensors, and smart pole. The bin sensor primarily shows about the fillness level in a live data application. And then the pit lever is something like a civic system, which basically tell us the basically fitness level at 49%. So once you go to 70%, we basically get some type of triggering, and the triggering will basically provide a report to the city council what they need to do. And the smart pole is primarily with the throughout the day, as you know, the sunlight changes. Sometimes it's rain, sometimes it's basically depending on the context of the day. So the bulb itself, which we are using LED bulb, will also change its it basically basically from 20% to 100% depending on the time of the day. Furthermore, it also affects the current voltage, which is being used by the light itself. So the conclusion that we have here is that IoT end-to-end solutions are enabling new generation smart applications, which is driven by primarily data. And as you know, the data is the next big thing, just like oil. It provides the acquisition of data from the source, which means the cyber-physical systems, such as it could be a factory floor, it could be a roads itself, it will be a home or building networks. Then it also provides a OT IT integration. This is very interesting because now imagine that you have an Active Directory, you have your IT infrastructure running in your company, and once you have an interoperable type of data coming out from the field devices or cyber physical systems, and the people which are accessing those devices is going to be somehow seamless or almost seamless integrated with your IT infrastructure, which is going to happen hopefully in a very near future. Next point is that it is also building context-aware real-time applications. So just imagine that the parking or the smart cameras that we deployed, those basically provide insights to the city council and those people which are managing those areas. So if let's say there is a market space or there is a commercial area, so based on the demography of the people, they can actually change their sales of the goods, or they can also provide sales according to the people which are coming in that area at that specific time. So those type of things are now possible as compared to before. Furthermore, from the city council perspective or a company perspective, these type of data which we are collecting would also give a optimization of the processes. Like I gave an example of what is happening with the sewage system in the city council. But in order to basically work on these technologies, and you also saw that it's a big market. It's like a $1 trillion market in different spaces. It also requires new skill sets which we need to develop, as well as new type of leadership, as well as people need to be trained from the technology perspective, from the management perspective, as well as from engineering perspective. I can give an example in the city council. There's an IT team which only knows about IT. There's a civil engineering team or a design team which only knows about design. Now, when we put a smart city project, there was a challenge. Who is going to manage a smart city infrastructure? So either they're going to introduce a new type of group, or they're going to create a subset of the group which consists of civil engineers and IT engineers. And I did mention a couple of times about data and the AI, and somebody, I think Umar asked me earlier, and Rahul asked me about some example for the machine learning and deep learning. As I mentioned earlier, that we have a 700 parking bays in that deployment area. So one thing which we did was, we basically created the data for 1 year or more than 1 year. And then we actually created a parking availability prediction system using deep learning. And what it does is, if somebody is going to a certain parking area and they are not sure that would they be able to get a parking, they can use the mobile app, which talks to the cloud system. And we have microservices running there, and other services which basically provides those insight of all the data. It will tell the person who's going to the direction what are the chances for them to get the parking. So this is also part of the machine learning, deep learning use case that we have done on a very simple parking data. The parking data that we are getting is a data which shows a car comes and park at this time and leave at this time. That's the data that we are getting with the ID. And using the data, we basically, we did the training, we go through with certain type of algorithms, and we found out that it makes sense for us to provide these type of services as part of the solution. So thank you very much for joining us, and I'll be happy to answer any questions that you have.
Thank you very much, Usman. So there are a few questions on the chat. We can quickly check those. If you can see there, one question that Jawad asked, that she wanted to know the IoT as part of AI. How we can consider both of them in the same way. Definitely, they are not the same way, but we can use them together.
Yeah, as I explained earlier, that IoT devices are primarily used for collecting the data or triggering an action. So the data is collected, goes to a high computing system, like something on the cloud or on server, and then you do AI, AI work on it, deep learning and machine learning model training, selection, and so on and so forth, which I explained earlier.
Mm-hmm.
The second question is, in my experience, AI, machine learning, and IoT work hand by hand. Observed one project where
that's actually the response. Zishan tried to give his
sure
on that.
Sure. Thank you, Zishan.
So there's another question: IoT impacting the word map applications.
What does it mean by word map application?
Like Google Map. That's actually, I was also trying to understand that question. Jawad, if you like to explain your question.
Yes, sir. Actually, I just wanted to know that, like, we have heard about Google Map application, and this is a product of Google, and how IoT will make impact on the map applications. Like, in the maps, there is a lot of navigation type. In the context of navigation, I would just want.
Yeah, so as you can see, the map that we are using, we purchase the Google Map, solution, and we use it for our platform. So generally speaking, there will be Google Map is provided as a service to different vendors, a platform, creator, and then they plot their own data on top of it. Now, Google can do the same thing. They can also pull data from open sources and provide the context of that data on the map, which basically again goes back to the data sources. So if the data sources are open, Google can use it, or someone else can call the Google API and put the data on it. Like in our case, we have a data which is still owned by the city council, so we can't make it open, and it's all basically within the closed system. But definitely it's possible.
That's, I think, all depends on the data sources and sensors. For example, if the different sensors for on different roads and different areas, they would like to place and they would like to get some data from that. So that depends on the need, that what kind of data or what kind of impact they are trying to have.
Yep.
So we have another question: which networking domain is prerequisite for IoT?
Actually, IoT is like, as I explained earlier, that we have different type of use cases or implement, like smart cities, smart homes, buildings, agriculture, and so on and so forth. Now, each of them, when they have sub-use cases, they have their own networking requirements. For example, if somebody needs to run, like the way we are running the LoRaWAN, we send the data once a day, minimum. And we're running with the, we know that we need a data which is only once a day. We want to run for a couple of years because we put the batteries inside. So we will, and we need a city infrastructure where it can go to, a couple of kilometers range. So we will choose LoRaWAN. But then if let's say I want to go like the way we have a smart lighting infrastructure there, smart lighting infrastructure, we are not using LoRaWAN because of certain requirements. Uh, LoRaWAN won't do bidirectional. Mostly LoRaWAN does one directional. So Zigbee can provide us bidirectional communication in the context of what type of devices that we get. So, I mean, networking domain itself is a big topic, but to simply make it as simple as possible, if you have a general IT networking background, that's a good to start with.
Okay, so there is another question: how can we implement IoT in Pakistan? And do we need some prerequisites?
Yeah. So in IoT in Pakistan, it depends on what are the challenging applications, what type of thing we want to monitor. For example, if in the case of agriculture application, which I worked almost 10 years ago for Malaysian government R&D, if we want to know about the soil quality, or we look at the moisture of the soil, and we know when to give the water, what type of pesticide to give, when to give. We can actually do tangible measurement, and based on tangible measurements, we can provide. We can put the IoT in the agriculture environment. Similarly, IoT could be also used in factories to improve the efficiency of the processes. But again, this is one of the discussion me and Mohsen and a couple of other friends used to have, that Pakistan has its own unique set of requirements, and based on those requirements, I believe that technology is there. It's only connecting the technology with the actual requirement to fulfill and make the solution for them.
Okay, and I think smart cities, smart homes, smart cities is a long-term project, but smart home can also be done in over here. Even on the agriculture side, as you mentioned, I have seen few projects are in progress, and on the university level, they are also doing it. But definitely, these are the areas where we can work on. Okay, so the last, yeah,
You're right. Just to add, very quickly, one of the good applications of IoT in a smart home environment is a security. What it means is you can put the sensors on doors, windows, and wirelessly it will monitor. So if somebody tried to open the door or windows, so you will basically get the notification on your phone. I'm personally using it in my house. Security is a good critical application for the smart homes.
okay, great. And there's another question: which sensors will be used? So I would like to answer, by the way, the different sensors for different applications and different requirements. So
Exactly.
mention,
it's a big line.
yeah, this is a big domain. So this is kind of question that which kind of drivers we would like to use. So definitely drivers are with respect to the devices, and sensors are also with respect to the requirements and the need that what kind of, for example, the security devices, there are different sensors for it. For agriculture, there are again different sensors. IR sensors mostly used, Jawad mentioned.
Yeah.
So,
I mean, different type of applications would require different sensors. So, for example, if you want to monitor the moisture of the soil, you will use a soil moisture sensor attached to a certain type of microcontroller. And let's just send over Zigbee.
And we also have speeding cameras installed in Pakistan. So I think they also have sensors to identify the speed of the cars. So that's also one example.
That could be another example.
Yes.
So definitely there is some work going on, and we will also be initiating different courses and different projects in Pakistan for IoT, and that's the reason we have started this webinar series. And through that, we will be making some awareness, and furthermore, we will also be launching some certified courses as well, so that we can help Pakistani people to get hands-on experience, like how they can develop IoT applications. So Usman will be with us for those kind of courses, and we will be offering these courses from Pasha and Agile Beams platform very soon. So that because this is the area that I can see that where Pakistan must have to improve for down the road, like 5 to 10 years, we should also be having smart cities. Okay, so I think that's it. It's already, we are already over time. So guys, if you have any question, you can post us, and we'll also share the recording on the YouTube channel. So thanks very much for joining in today. Thanks for your time over the weekend. Thanks, Usman, for giving your time.
Thank you very much, everyone, for joining.
Take care. Allah Hafiz.
Allah Hafiz.